This is section 1.6 and 1.7, representing functions as rules, tables, and graphs. We have a lot of new vocabulary for this section. So first, a function is a rule that establishes a relationship between two quantities. These two quantities are called the input and the output. So for a function to be a function, each input has to have exactly one output. In other words, x values cannot be repeated. We also have domain, which is the collection of all input values or x values, and range, which is the collection of all output or y values. And then finally we have the independent variable, which is another name for the input variable or quantity, and then we have the dependent variable, which is the output variable. One way to think about a function is with the help of a function machine. So we can think about the input going in, the function doing something to it, and then the output is what comes out. So if you remember from our previous slide, input is the same as x, and domain, and also our independent variable. And then outputs we can also think of as our y, or our range, or the dependent variable. So think, what comes out is dependent on what happens inside the machine and what gets put in. So here's an example using the function machine. So if we have x equals 4 goes in, well then we plug 4 into this equation because that's what's happening inside the machine. So 2 times 4 plus 3, well that's really 8 plus 3, which is equal to 11. So that's our output, or our dependent variable. Okay, so there's several different ways that we can represent functions. You might see them in a list form. So it's just ordered pairs listed out from left to right. You might see an input-output table where we've listed x and all the x values, and then y and all the y values. And it doesn't matter if it's horizontal or vertical. And then also we can represent a function with a graph. So whether that's a graph with points like you see here, or a graph where it's connected and continuous. We also can represent functions with a verbal rule. So for example, each second coordinate is 2 more than its first coordinate. So if we were to translate that verbal rule, another way we can represent a function is with an equation. So in this case, that becomes y equals x plus 2. And then the last thing, which might be new, is called a mapping diagram. So you have two kind of ovals usually. And on the left, you have your input or your x values. So maybe we have 1, 2, 3. And if we're to plug them into our equation up above, our output would then be 1 plus 2 is 3, 2 plus 2 is 4, and 3 plus 2 is 5. And the mapping diagram tells us which output each input is mapped to. So 1 is mapped to 3, 2 is mapped to 4, and 3 is mapped to 5. So part of what you have to be able to do is to decide if something is a function or not. So if you see something in list or table format, no x-coordinates should be repeated. So if any x-coordinates are being repeated, then you know it's not a function. If you have a mapping diagram, no domain element should have more than one arrow coming from it. So we'll see an example of that later. When you have a graph, we decide if it's a function using something called the vertical line test. So basically, a vertical line drawn anywhere on the graph shouldn't cross it more than once. And again, I'll show you an example of that. Okay, so on your note sheet you have example, non-example. Make sure you write yourself an example and a non-example for each type. So first, we have this list of ordered pairs, and you can see that 0, 0, 1, 1, 2, 4, 3, 9, none of the x values or inputs have been repeated. So that is an example of a function. In the second list here we have 2, 1, 3, 2, 2, 4, and 4, 7. And this time 2 is repeated. So this list is telling us that 2 gets mapped to 1, but 2 also gets mapped to 4. And remember, our definition of a function says that every input has exactly one output. So this is not a function. Our last example, we have 0, 5, 1, 5, 2, 5, and 3, 5. And this list is actually a function. It's a little bit tricky because they do have the same output value, but by definition of a function, all we need is for each input value to match to exactly one output. So that is a function. Here are two tables. So on the first one, 0, 4, 2, 6, 4, 8, 5, 9, x doesn't repeat, so that is a function. But on the right, 4 is mapped to 0, and 4 is also mapped to 1, which violates our rules for a function, so that is not a function. Here's some more mapping diagrams for you. So here, 4, 8, and 2 are all mapped to exactly one output, so that is going to be a function. Down here in the middle, 0 has 2 arrows coming from it, so this is telling us that 0 is mapped to 2 and 0 is also mapped to 3, so that cannot be a function. In the top one, again, all we care about is if the inputs have exactly one output. So in this case, even though they all map to 6, this is a function. Our last example are with graphs. So remember I told you we have something called the vertical line test. So if you can imagine just sort of taking your pencil or pen and putting it upright like a vertical line and dragging it from left to right across the function, that'll tell you whether or not it is a function. So this first one in the top left, if I were to take my pen and hold it vertically and take it from left to right, it would never touch that line in more than one place. So we could draw a line anywhere on here and it would never touch that line in more than one place. So that is a function. Moving over to the right, again, if you were to drag your pencil from left to right, it would never touch that in more than one place. So that is a function. Down in the bottom, we have two non-examples. So a vertical line automatically fails the vertical line test because if you draw a vertical line, it's clearly touching it in more than one place. So that cannot be a function. A circle is another example of a non-function because anywhere you draw a line, it's always touching it in more than one place. So to make sure you understand what I'm saying, see how this first line I drew is touching it down here and up here? That is what can't happen with the vertical line test, so that is not a function. And that's it for this section.